Welcome to Astronomy Daily. I'm Anna with your daily dose of space and astronomy news. We have a great lineup of stories for you today, from groundbreaking discoveries about water formation in the early universe to the latest developments in space exploration. We'll dive into fascinating new research suggesting that the first supernovas may have flooded the universe with water just 100 million years after the Big Bang. We'll also check in on Rocket Lab's first launch of 2025 and bring you breaking news about major changes potentially coming to NASA's Space Launch System program. Plus, we've got intriguing discoveries about a possible supermassive black hole in one of our nearest galactic neighbors, and evidence that some asteroids in our solar system might be ancient planetary fragments. So, let's blast off into today's space news. In a groundbreaking new study, scientists have discovered that the universe's first supernovas may have created vast amounts of water much earlier than previously thought, potentially setting the stage for life just 100 million years after the Big Bang. This fascinating finding challenges our current understanding of how water formed in the early universe. Until now, scientists believed that water gradually accumulated over billions of years as hydrogen combined with oxygen expelled from dying stars. However, new simulations suggest a much more dramatic origin story. When the first generation of massive stars exploded as supernovas, they may have created the perfect conditions for water formation in their wake. These early stars were true cosmic giants, each containing about 200 times the mass of our sun. When they exploded, they left behind dense clouds of hydrogen, oxygen, and other elements. Within these cosmic clouds, water could have formed at concentrations up to 30 times higher than what we observe in interstellar space today. If confirmed, this discovery would have profound implications for our understanding of both galaxy evolution and the potential for early life in the universe. It suggests that one of life's most essential ingredients was present in significant quantities far earlier than we imagined, potentially seeding the first galaxies with water between 100 and 200 million years after the Big Bang. However, this theory isn't without its challenges. Scientists have never directly observed these early stars, and if there was such abundant water in the early universe, we might expect to see more of it in our cosmic surroundings today. Some researchers suggest the universe may have undergone a mysterious drying out period, though the mechanism for such an event remains unclear. While water is crucial for life as we know it, its early presence alone doesn't guarantee that life emerged during this period. Nevertheless, this research opens up exciting new possibilities about the conditions present in the infant universe and challenges us to reconsider our assumptions about cosmic evolution. Next up in today's news, Rocket Lab is gearing up for an exciting start to 2025 with their first orbital launch of the year scheduled from their Launch Complex 1 in Mahia, New Zealand. The mission, cleverly named IoT for You and Me, is set to lift off this Sunday morning local time, carrying a valuable payload of 5 satellites for the French Internet of Things company, Kinéis. This launch marks another important step in expanding global satellite coverage for the Internet of Things. Each of these satellites, measuring just over 4.5 by 5 feet, will be placed into a circular orbit about 400 miles above Earth's surface. They'll be traveling at an incredible speed of nearly 5 miles per second, powered by electric propulsion systems and solar panels. The mission is particularly significant, as it represents the fourth of 5 dedicated launches needed to complete Kinéis's ambitious constellation of 25 satellites. Once fully deployed, this network will ensure continuous data transmission with up to 80 satellite passes every day over any point on the globe. The launch was originally planned for earlier this month, but had to be postponed due to a potential collision risk with the International Space Station. This kind of careful coordination and safety consideration is crucial in our increasingly crowded orbital environment. Rocket Lab continues to demonstrate its reliability in the small satellite launch market, providing regular access to space for companies looking to expand their orbital infrastructure. This mission reinforces their position as a key player in the commercial space industry, while helping to build out the global Internet of Things network that will connect devices and sensors worldwide. In significant news from the aerospace industry today, Boeing has issued a stark warning about the future of NASA's Space Launch System program. During a hastily arranged 6-minute meeting, Boeing's vice president and SLS program manager David Dutcher informed approximately 800 employees that their contracts with NASA could end as soon as March, with potential layoffs looming on the horizon. This development comes as Boeing prepares to issue notices under the Worker Adjustment and Retraining Notification Act, potentially affecting around 400 positions by April 2025. The timing of this announcement aligns with the anticipated release of President Trump's budget proposal for fiscal year 2026, suggesting possible major changes to NASA's heavy lift rocket program. The SLS program, which has been a cornerstone of NASA's space exploration efforts since 2011, has faced ongoing scrutiny due to its high costs and delays. Each launch of the massive rocket costs over $2 billion, not including payload or ground systems expenses. While the rocket finally made its debut flight in late 2022, this came years behind schedule and billions over budget. What makes this situation particularly notable is the changing landscape of space launch capabilities. Private companies like SpaceX and Blue Origin have developed their own heavy lift rockets that are not only partially reusable, but operate at a fraction of the SLS's cost, less than 1/10, in fact. There's reportedly been significant debate within NASA and White House leadership about the future of both the SLS rocket and the broader Artemis Moon program. Some advocate for completing the planned Artemis 2 and 3 missions using the initial version of SLS before ending the program, while others argue for an immediate cancellation to prevent further cost overruns. This situation highlights the ongoing evolution in space launch technology and the challenges facing traditional government-contracted space programs in an era of increasing commercial competition. The outcome of these developments could significantly reshape NASA's approach to deep space exploration in the coming years. Time for today's black hole story. In fascinating news from our cosmic neighborhood, astronomers have uncovered compelling evidence of a supermassive black hole lurking in the Large Magellanic Cloud, one of the Milky Way's satellite galaxies. This discovery came through an unexpected source, hypervelocity stars racing through our galaxy at incredible speeds. Using data from ESA's Gaia spacecraft, researchers found that about half of the previously identified hypervelocity stars in our galaxy can be traced back not to the Milky Way's center, but to the Large Magellanic Cloud. These stellar speedsters are traveling at up to 1,000 kilometers per second, 10 times faster than typical stars. The research team constructed detailed models showing that these high-speed stars were likely ejected by a black hole in the LMC with a mass of around 600,000 times that of our Sun. This process occurs when binary star systems get too close to the black hole, resulting in one star being captured, while the other is violently flung away at extreme velocities. Further supporting this theory is a peculiar concentration of stars known as the Leo overdensity. The researchers' models show that this stellar gathering is consistent with stars ejected from the LMC by its hidden black hole. This discovery challenges our current understanding of dwarf galaxies like the LMC, which weren't thought to harbor such massive black holes. This finding has significant implications for our understanding of galaxy evolution. If astronomers have been missing black holes in smaller galaxies like the LMC, our theories about how galaxies grow and develop may need substantial revision. It also demonstrates how the motion of entire galaxies can influence the dramatic stellar ejections we observe, adding another layer of complexity to our cosmic understanding. An intriguing discovery has astronomers rethinking the early history of our solar system. 2 asteroids floating in the main asteroid belt between Mars and Jupiter might actually be ancient remnants of planetary embryos from our cosmic neighborhood's earliest days. These asteroids, named Asperina and Lou Allen, share remarkable similarities with a rare group of meteorites called angrites, which are some of the oldest known rocks in our solar system. This connection is particularly exciting because it could provide a direct link to the tumultuous period when our planets were first forming. Scientists reached this conclusion by comparing the light signatures of these asteroids with samples of angrite meteorites found on Earth. The larger of the two, Asperina, spans about 32 miles in diameter and likely represents a significant piece of a much larger ancient body, possibly one that was closer in size to the Moon or Mars. The discovery of these potential planetary fragments offers us a unique window into the violent early days of our solar system. During this period, numerous planetary embryos, bodies larger than asteroids but smaller than fully formed planets, collided and merged as they grew into the planets we know today. Many were destroyed in the process, leaving behind only fragments as evidence of their existence. If confirmed, these asteroids could be some of the last surviving pieces of long-lost worlds, preserving crucial information about how planets form and evolve. Their study might help us better understand not only our own solar system's history, but also the process of planetary formation occurring around other stars. And that brings us to the end of today's episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me on this journey through the latest developments in space and astronomy news. If you're hungry for more cosmic content, head over to our website at astronomydaily.io. There you can sign up for our free daily newsletter and stay up to date with our constantly updating news feed of space and astronomy news. You'll also find all our previous episodes available for listening at your convenience. Want to be part of our space-loving community? You can find us across all major social media platforms. Just search for Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, and TikTok. Until next we meet, keep looking up and stay curious about the wonders of our universe.